Welcome, students. We know that in the complete communication system, you need two devices. One, the device which transmits the message signal is known as transmitter. Another device which receives the message signal is called receiver. So, in the transmitter stage, the message signal is low frequency, audible frequency. Therefore, you have to mix this with very high frequency in order to communicate it to a longer distance. That process of mixing up of high frequency with low frequency is called modulation. That happens in the transmitter. Whereas in the receiver, we will receive the signal, that is modulated signal, and we will separate the message signal from high carrier frequency signal. Since our message signal is priority, we will remove carrier frequency and you will get only message signal. Thus, the receiver will reproduce the original message signal. Now, today we shall discuss about receiver. We have already studied about transmitter, frequency modulated transmitter, FM transmitter. Today we shall discuss about frequency modulated, that is FM receiver. Here, FM superheterodyne receiver we are discussing. Heterodyne is nothing but process of mixing up of two different frequencies, and it produces a beat frequency, that is sum of the frequency and difference of frequency, in which sum of frequency is removed, we get only difference of frequencies. This is called heterodyne process. So in FM super heterodyne receiver, we will apply the signal frequency and also we will apply the local oscillator frequency. These two frequency are mixed and produces difference in frequency, that is heterodyne frequency. This difference in frequency is called intermediate frequency. Okay, however, you have only qualitative explanation of heterodyne receiver. That is, you have to explain only the block diagram and its function. Each block diagram has its own circuit and you have no working of that circuit, and also you have no circuit. Only the block diagram. Inside the block diagram, there is a circuit. The name of the circuit is mentioned in the block diagram itself. First, RF amplifier, mixer, IF amplifier, limiter, discriminator, local oscillator, and etc. etc. So, there is an electronic circuit inside the RF amplifier. There is an electronic circuit inside the mixer. Here we are going to explain what that does. That's all. And we don't have any working conditions and circuit. Now, this is a complete block diagram of super heterodyne receiver, FM super heterodyne receiver. Up to this spot, it is similar to, up to this spot, from RF, mixer, IF amplifier, local oscillator, ganged capacitor, this ganged, up to this, it is similar to AM super heterodyne receiver, because it has to pass through heterodyne process. Therefore, it is similar. But in AM receiver, we will separate the carrier signal from message signal by AM modulator. In the FM receiver, we will separate the message signal from the carrier frequency signal by a demodulator. There is also demodulator, but AM demodulator. Here also demodulator is present, but it is called FM demodulator. That is the only difference. See, the transmitter will transmit the signals, and you have many transmitters on the earth. So many stations will send out many message signals. At the receiving station, first the antenna is the first element. This antenna receives the signal from all parts of the transmitter. So it receives all frequencies. While traveling into the space from the transmitter, the signal becomes weak because it has already traveled a long distance, and gradually their amplitude decreases. At this stage, when it is received by the antenna, it becomes very weak, that is, it becomes feeble. Therefore, the first stage is you have to amplify that signal. So, this antenna receives the frequency modulated signal from the transmitting antenna. Since it becomes weak, it has to be amplified to the required level, and the signal received is very high frequency. It is known as RF frequency. Therefore, this circuit RF amplifier will amplify the received signal. And there are three important characteristics of the receiver. You have already discussed in AM transmitter, AM receiver. That is selectivity, sensitivity, and fidelity. I will explain once again what is fidelity, what is sensitivity, and what is selectivity. Okay, this antenna, receiving antenna, receives the signals from all station, and also while traveling it becomes very feeble. Therefore, this RF amplifier should be very sensitive to receive even weak signal. It has to be very sensitive to receive even very weak signal from this antenna. That is called sensitivity. And this RF amplifier has to receive only the particular station message signal, and it has to reject all other unwanted signals. That means the RF amplifier has a tuning circuit. This is a tuning circuit. Tuning circuit is parallel combination of L and C. This is L and this is C, where the frequency of this is given by F is equal to 1 over 2 pi root LC. Let us consider a variable capacitor. When C varies, the ratio varies, F also varies. However, this antenna receives all frequencies. Now you can select the value of C so that it will select only a particular station frequency, which is given by this, and it rejects all other frequency. Selecting a particular frequency from different stations is called selectivity. It is another important characteristics of a receiver. Receiver should have this character. And fidelity, that is feeding capability. Once it receives the signal, it should be able to feed to the next stages. That is called fidelity. So these three are the important characteristics of any receiver, AM receiver or FM superheterodyne receiver, whatever it may be. Okay, we will discuss this later. This antenna receives the signals from all stations. There is a tank circuit in this RF amplifier here. The value of C is selected such that F is equal to 1 over 2 pi root LC is the value of the frequency. That means RF amplifier will receive only that frequency and rejects all other stations frequency. Now it is first amplified by RF amplifier. Since the signal received is very high frequency, that is radio frequency, this amplifier is called radio frequency amplifier. It only strengthens the high frequency signal. Okay, next, for heterodyne, that is to get mixing up of frequency, This is our signal frequency received. I will call it as Fs. And to get a difference of frequency, you have to create another frequency locally by any oscillator. That is called local oscillator. This local oscillator creates a frequency locally. Let it be denoted by F naught, oscillator frequency. Fs is signal frequency, F naught is oscillator frequency locally created by a local oscillator. Then the frequency from the RF amplifier, that is signal, the particular signal frequency Fs, and the frequency generated from the local oscillator, that is F naught. These two are applied to the input of a mixer circuit, where this mixer circuit produces difference of frequency and also sum of frequency, that is called BEAT, beat frequency. Therefore, you get Fs plus Fo, or Fo minus Fo, Fo plus Fs, Fo minus Fs, in which Fo plus Ff is removed to the ground. Only the output of the mixer is difference of these two frequency. Usually we make oscillator frequencies more than the signal frequency. Okay. Oscillator frequency F naught is made more than the signal frequency received. Therefore, the difference in frequency produced by the mixer is F naught minus Fs. Now, this difference of frequency is called intermediate frequency. You know the value of intermediate frequency for AM receiver. All over world, the AM transmitter intermediate frequency is fixed to 455 kilohertz, whereas the FM superheterodyne receiver, in which the difference in frequency, that is intermediate frequency, is fixed to 10.7 megahertz. It is a constant value. That is, whatever the signal received from the antenna, you have to create a local oscillator frequency F naught such that the difference should be 10.7 megahertz. That is called intermediate frequency. Now, this intermediate frequency is amplified by an amplifier circuit. Since this amplifier circuit amplifies the intermediate frequency signal, it is called simply intermediate frequency amplifier. Now, this output of the intermediate frequency amplifier is fed to the limiter. It is an electronic circuit limiter, where it limits the amplitudes of this signal. So, it limits the amplitude of the frequency modulated signal here. Then it is frequency modulated signal is then applied to the discriminator. Discriminator is also called demodulator. Usually this discriminator in the FM heterodyne receiver, this discriminator is Foster-Seeley discriminator or slope detector. The slope detector or Foster-Seeley discriminator will detect the message signal from the frequency modulated signal. How do you get frequency modulated signal? The normal carrier frequency Fc is varied in accordance with the amplitude of the message signal. It is varied in accordance with EM, and you get a frequency modulated wave such that the real frequency Fc is maximum for maximum values, and it is minimum for minimum values, and it is equal to Fc itself at the point 0 amplitude. Therefore, this Fc plus or minus delta F is called the carrier deviation from the value Fc. This carrier deviation depends upon this amplitude of the modulating signal that we have already discussed in the frequency modulation. So, this frequency modulation consists of Fc plus or minus delta F. This carrier deviation delta F is changed into modulating signal. It is changed into the modulating signal. This is our message signal. Okay, the output of the limiter is the frequency modulated signal. It is then applied to the discriminator. It is a demodulator circuit, usually slope detector or faster Sealy discriminator. What it does, this faster Sealy discriminator or slope detector will detect our message signal from the frequency modulated signal. Thus, carrier deviation delta F is converted into corresponding amplitude variation. It is reverse process of frequency modulation. Now, after this discriminator at the transmitting station, what we did first, to improve the signal to noise ratio, we have increased the amplitude of the signal, high frequency signal, with respect to amplitude of the low frequency signal, that is called pre-emphasis. Here we do in the reverse process, that is, we will reduce the amplitudes of the high frequency carrier signal with respect to the amplitude of the low frequency carrier signal. So in the transmitting station, signal to noise ratio is increased for better transmission. Here once it is received, now signal to noise ratio is not important. Therefore, it is de-emphasis. This de-emphasis network reduces the signal to noise ratio, or in terms, it reduces the amplitude of high frequency signal with respect to the amplitudes of low frequency signal. We know that our voice signal has frequency ranging from low frequency 20 Hz to high frequency 20 kilohertz. That amplitudes are limited. That's amplitudes are de-emphasis. And after de-emphasis, it is then amplified by AF power amplifier. Usually this is AF amplified. We call it as AF power amplifier. That means this is our message signal we are getting from the output of this. If this amplitude is not sufficient, then we will raise this amplitude to the desired level we require. Since it is AF signal, this amplifier is called AF power amplifier, where power level of this message signal is raised. This raised power is then applied to a loudspeaker. This loudspeaker does the opposite function of microphone. At the transmitter, our speech is converted into electrical signal. That is, mechanical signal is converted into electrical signal by means of microphone. Here the electrical signal, audio frequency power electrical audio signals, is converted into mechanical signal. That is our original voice. And this device is called loudspeaker. Loudspeaker converts electrical signal into mechanical signal. Microphone converts mechanical signal into electrical signal. Therefore, at the transmitter we use microphone. At the receiver, finally, we use loudspeaker, which produces or reproduces the replica of the original sound. So, what sound is transmitted from the transmitter, it is produced back at the receiver. So, this is a simple block diagram of superheterodyne receiver, frequency superheterodyne receiver. You see here, RF amplifier has a capacitor here in order to select a particular frequency. Mixer also has tank circuit. Okay, and this local oscillator, to produce frequency, there must be a tank circuit. This local oscillator frequency, where L is connected in parallel. This is L and C naught. I will call this as C naught. Therefore, F naught is equal to 1 over 2 pi square root of L C naught. This is F naught, frequency produced by local oscillator. All this frequency produced must be in such a way that this output F naught minus Fs is the intermediate frequency. Therefore, we will not change the values of capacitor of each circuit one by one. We will simultaneously change the capacitance values of this RF tank circuit of RF tank circuit of mixer, tank circuit of local oscillator. All the capacitors of the tank circuit of RF mixer and local oscillator are simultaneously changed. They are simultaneously changed. Therefore, all these capacitors are connected to a single capacitor, that is ganged capacitor, and the tuning is known as ganged tuning. And also due to component transistor component, and it may be heated up, all this may consist of transistor, it may be heated up due to some variations properties of inductance, resistance, and all other electronic components, the frequency may alter. Therefore, what we do is, output of this discriminator, we will take the output of the discriminator and connect it to AFC, that is called automatic frequency control. Then it is fed to the local oscillator, so that the local oscillator frequency changes such that F0 is more than Fs by an amount 10.7 megahertz. This is for FM. And also one more important in this is AGC, automatic gain control. That is, each stage when you apply input, the output is gained, because this is an amplifier circuit. This is an amplifier circuit. When you apply input, the output is gained. Therefore, to keep the gain constant, you have to apply automatic gain control from limiter to all these three: IF amplifier, mixer, RF amplifier. So we are applying this to all these three with a circuit known as automatic gain control circuit. So this is a simple functional block diagram of FM super heterodyne receiver. Thank you very much.